Hi everyone, and welcome to this chapter of Dart Crash Course. In this chapter, we're going to talk about mixins. Let's do the usual dance. I'm going to bring up our terminal, and let's go ahead and say Dart creates with a template of console a project called Mixins. All right, we can't use any reserved words, but mixins is not a reserved word in Dart, so or it's actually not a reserved word as a package name. So it's a valid package name, okay? And let's go ahead in Mixins in here. Actually not CD, but we should have just done code, I would say. So let's just go back here like this. We do a zoom level of 6 usually, like this in here. And let's go ahead into the bin folder, delete the usual first initial file in there and say example1 Dart. We create a main, and also inside terminal we say fswatch with example1 like this, and get rid of that there. So now let's talk about actually what mixins are. So mixins are like separate entities that can bring functionality to existing classes and enumerations. So whereas your usual functions, you either create them at top level of your application or inside a class or inside an enumeration, mixins allow you to create functionality or functions, variables, properties inside the mixin, and then bringing the mixin into various enumerations or classes. And in that way you can basically have kind of like simulate multiple inheritance. So let's say that you have two classes, and let's say you have a class A and class B, and class C and wants to inherit the functionalities that are inside A and B. Since Dart does not have multiple inheritance, you wouldn't be able to do that without reshuffling the hierarchy of class A and B. So that, for instance, class B inherits from class A, and then class C inherits from class B. In that way, then you'll go basically from A to B to C. Okay, so that's like the class hierarchy, and that's how you would be able to do that and achieve that. But if you had class A and B, how could you have C inherit from both of them? And you can't do that. The solution to this usually is that you either think about your designs. I don't mean the UX and the UI design. I mean like how you've designed your program, so that you don't have to have inheritance in that way. Because usually what happens is that you'll have one function, perhaps in class A, that class C also needs, and C comes from B. And then you say, just because this A class has that one function that C needs, I'm going to bring A here as well, so that C can inherit from A as well. And that's usually a bad idea, because just because that one function is needed here, you don't have to just change the entire program structure. And that is exactly why we have mixins. So mixins are entities that can include those functions that we just talked about, for instance, or we just talked about. And then you can say, okay, both, for instance, B and C take in that mixin, so that they can basically use the functionality, and A also perhaps does the same thing. So in that way you can bring like functions and functionalities, meaning that properties and functions, into various entities without having to even have multiple inheritance, and that's something that Dart doesn't support anyway. So without further talking about that, let's just go ahead and have a look at some examples. Okay, so how you would create a mixin is by just typing mixin, and that is a reserved word in Dart. Okay, let's create a mixin in here and say has speed. All right, and then we create an abstract double property in here called speed. Okay, so this is literally saying a mixin, and that is called has speed. And then we have to have a speed property on the types that implement this. All right, then we can have, for instance, another mixin in here, and we say mixin can jump, and we will implement this can jump on this mixin. So a mixin that is implemented on another mixin, let's say on has speed. All right, then we create a function in here and we say jump. You can see you can create a function inside a mixin just as you would create the same function on a class. So let's say that we have jump function in here. And let's go ahead and ask for a required name property in here. We say, required name parameter. And we say double at what speed we should jump. Okay, then in here we just say print runtime type is jumping at the speed of $speed. All right. And since this mixin is created on top of this mixin, then it has access to this property. So if you say this dot speed, you can see you have access to it. And that's because you're referring to this particular speed right here. Okay. So and if you look at this, you'd be like, but wait a minute, this is not even a final property. What does it even mean? Remember, mixins, when they do like abstract properties like this, it's a contract. It means that whichever type, meaning that an enum or a class that implements this or actually brings it in as a mixin, has to have this property. Therefore, any other mixin that is implemented on top of this mixin can have access to that property, meaning that, well, it's part of the contract. This mixin, the super mixin in here, says that I have a speed property, so let's just use it. Okay, so in here we say this speed is equal to speed, like this. All right, now we can have another mixin on top of our has speed that we can call can walk. All right, so let's copy can jump, bring it here, and we say can walk like this, and then we change the function from jump to walk, and then we keep the speed, and then in here we say runtime type is walking at the speed of speed, just like that. All right, now the interesting part then is when we start using these mixins. So let's go ahead and create a person class, and we say now we want to use these three mixins: has a speed, can jump, and can walk. So we want to say a person can have speed, and we can say it can jump and it can walk. All right, so let's say has speed with has speed, so we don't say extends or we don't say implements. When it comes to mixins, we say with, okay, has a speed. And we can also have multiple mixins in here. So we say can walk and can jump. And you can see we're getting a little error in here, and simply because the has speed mixin, if you remember, as part of its contract, indicated that whichever type implements this, mixes this mixin in, and when I say implements this mixin, we should probably just know that it's bringing it in using the with keyword. Whichever type is using this mixin or bringing it in with the with keyword has to implement this property, the speed property. And this is the error that we're getting in here, saying missing concrete implementation of getter has speed. So we can get Visual Studio Code to add this missing property here for us. Okay, so we get double speed. And also, since this is a property that is not nullable, we have to have a default value for it. So let's say in the constructor for person, we just say speed is 0. Okay, so you could either do this, or I think you could also do this and remove the constructor. So whichever one you prefer, I'm just going to leave it as the constructor in here. Okay, so let's now go ahead and use this person class. We could easily do this by creating an instance of person. So we say person is an instance of person. Now you can see person has a property called speed, and it also has the jump and run functions, and jump and walk, right? So in the jump function, we'll give it a speed of, let's say 10, and we say person walk with the speed of 5. Something like this. Actually, it doesn't really matter. It doesn't have to be realistic. Let's just leave it like this. And then we can have a look at the example, the terminal. You can then see it says person is jumping at the speed of 10, person is walking at the speed of 5. Now, these really don't mean anything. I mean, what speed? Is it kilometers? Are you jumping at this? I don't know. So it's just a number. It's for demonstration purposes, okay? But I think you get the point. So the point is now, since person is conforming to has a speed, then it has access to enable also jump and walk. And remember, you can remove these walk and jump from here, and all of a sudden you only have access to has a speed. So you don't have any more access to jump and walk. But if you go and bring can walk, all of a sudden you have access to the walk function, but not the jump function. And in here, you can also say can jump. And remember this, now, if you try to remove has a speed, then you get an error in here simply because it says can walk. This mixin has been brought on top of has a speed. So you see can walk in here. It requires this type that is using can walk to also conform to has speed. And this is what we're getting in here. The error says can walk can't be mixed onto object because object doesn't implement has speed. So we've created like a hierarchy in here saying whoever wants to use the can walk and whoever wants to use the can jump mixins has to also have brought in the has speed mixin. And really the reason behind this is that these two can jump and can walk are requiring a speed property. Without the has a speed, Dart cannot guarantee that the type implementing can jump and can walk actually have this speed property, even though it is here. Okay, but Dart can't really contractually agree that yeah, this is something that the user is actually doing. So therefore we need to bring in has speed, and then I think actually we can bring has speed even after these, and it still doesn't. Oh no, okay, so it has to be before. Okay, definitely. So has speed seems to have to be first, and then we can bring in the others. It was a little bit strange though. I mean, I think this should also be valid syntax. But it seems like it has to be in that order. But I don't think can walk and can jump need to be in any specific order. They can be in any order they want, but it seems like the parent mixin has to appear first. Okay, good. That was our first example. So you've seen now how three simple mixins can coexist in the same Dart file. Okay, so let's go to the next example. So I'm gonna close this file in here and let's create example2.dart. The usual dance, the main function, and of course also fswatch in here. And let's just save this file, get rid of the terminal, and let's start talking about mixins and conformance using functions. So mixins are data types themselves. So in this example, what we're going to have a look at is to accept a mixin as a parameter of a function. Okay, so let's create a mixin in here. And so mixin has first name. So here's a mixin that requires a string for, actually this is exactly what I want to type, so this is really great. So you can see this mixin is requiring any type that conforms to have a string getter property called first name. And you can guess it, we're going to have also a mixin for last name, as says, okay, whichever type implements me has to have a last name getter property of type string. Okay, then you can see, okay, well, we have a first name and last name. Can we create one that creates a full name out of these two? So we can say, you see, I'm actually thinking just like conceptually. Any data type, any class, for instance, that has a first name and a last name getter can perhaps get a free property called full name. And this full name will then calculate the first name and last name and just put space between them, and will just provide you with that. It's kind of as if you say, okay, if you have this item and that item, then, well, you should have another item called this. Okay, so it means, like, for instance, if I say, well, if you have 20 kilograms of luggage and clothes, then you have to also have a carrying bag, something that you can actually carry it with you, a suitcase. So you can't just appear at the airport with just 20 kilograms of like unsorted clothes in your hand. If you have those 20 kilograms of clothes and belongings with you, you have to have a carrying bag or some sort of a suitcase. And this is what we're saying in here. We're saying that if you have a first name and last name, then you definitely have a full name, because we can construct a full name out of first name and last name for you, right? So let's create that mixin. So we're going to say mixin, and we say has full name like this, and we say, well, this has full name requires the first name and last name. Therefore, we say this mixin is on has first name and last name, and therefore we will provide you in this mixin, as long as you conform to these two mixins, a property called full name, which brings in the first name and last name together using a space in between. All right. Then what we'll do, we'll create a person class in here, and we'll say, okay, with has first name, has last name, and then has full name, okay, like this. Then we'll create overrides of these getters in here. String, you see string get first name and last name. I think Visual Studio Code can do that for us. There we go. And let's remove these two dudes from here, okay? And we don't have to have like these throws. And also you see what we're going to do in here, we're not going to have these as getters, we're actually going to have them as final properties. So we say final string and final, okay? And the reason this works is that according to the contract, has first name requires us to have a property called first name, which this mixin can read from. And also a final string property named the same can be read from. So it is fulfilling the contract, though it's not written in the exact precisely same way as the contract says. Okay, the contract says give me a first name, and this guy says, oh yeah, I will do a final property which you can read from. Okay, so as long as you're fulfilling the contract, it doesn't really matter which syntax you write it. All right, so this is fulfilling the contract of that getter. Now let's go ahead and create a constructor for this with required named parameters like this. Okay, and you can see all errors have now disappeared. So we have our person. Now that we have this, let's go ahead and just create a simple function in here. And this is just for demonstration purposes. You usually wouldn't do this, but let's create a function and say, this function is called get full name. And then we'd say, okay, but it has to return a string. But what data type should it accept in here? Should it be a type that is of type person? But maybe there are other types that conform to the exact same three mixins and have a full name property. So what should we accept? Should we just bring these three in here? Should we just go ahead and say, these three are the data type that you pass in here? But no, if you separate these with a comma, they become separate parameters. So what should we do? Well, the answer is just to say has full name. And then we say an object, because has full name brings with it these other two mixins, meaning that if we have an object that conforms to has full name, it should also conform to has first name and has last name. And that's what exactly this syntax does. So as long as we take has full name, then we have access to first name and last name, and of course the full name property. So in here, we just say object full name. All right. So good. Then let's go ahead and say we have John Doe in here, and we say this is a person whose first name is John and last name is Doe. And then we can go in here and say print John Doe's full name. This is a property directly on John Doe simply because it conforms to the has full name mixin. And of course, you can then pass this John Doe to the get full name function because John Doe is conformant to has full name mixin. So let's say we then print get full name John Doe as well. And you can see in both cases, it's just going to say John Doe. All right. Because this full name was calculated. So this particular full name was calculated in the has full name mixin. And this get full name is delegating the task to the same property, full name, and just returning that string. And then we're printing it. Okay, so they're pretty much doing the same thing. But this particular example just wanted to demonstrate how you can actually accept a mixin as a data type into a function call, which we're doing here. Okay, good. We're done with example 2. Let's create example 3.dart, the usual dance. We've done this so much now. I think we've gotten all really fast at this task. Okay, and then we can close our terminal. I think I use control and backtick to close my terminal, like this and like this. So it is actually a good, and this is the backtick character I was talking about. I do that on Mac OS, and I think it's control backtick on Windows as well. The challenge here is actually finding the backtick on your keyboard. On your keyboard. So as soon as you find it, and for me, like on Mac, it sits on top of control. So it's literally the key on top of the left-hand side control. All right, enough about that. Let's now talk about mixins with logic. And just as mixins can have properties, they can also have just simple functions as well, for instance. So let's create a mixin and we say has age. All right, has age in here. And we say it has an abstract property and we call int age, just like that. And then we can say increment age. And the only thing this function does, as you can see, it just increments that age. It's very simple. I mean, we're just saying that we have a property called age and we're incrementing it inside this function. So then we can say a class cat with has age. We override the age. Of course, we have to do that contractually. So if I go in here, you can see we can't compile this application. So let's say that we have this age property here. And then, of course, we're going to go ahead and accept this as a parameter. I think it would be really good if whoever created an instance of cat could actually pass the age as an argument to our constructor. So let's say cat, and we then say required this age. Okay, this is really nice because then whoever creates an instance can provide the age as well. So just as you'd expect, you can go ahead and create in here a whiskers, for instance, a variable, and we say it's a cat with the age of two, and then we say print whiskers cat, whiskers at age. And then this is going to print the value of 2 for us. There we go. And of course, since cat conforms to the hasAge mixin, then it will get a free increment age function in here. So let's say whiskers dot increment age. All right. And then we say print whiskers dot age. All right. So you'd be thinking then, but can I have this as a const? Right? And then go and say final int age, but that won't work really. And the reason behind this is that this mixin didn't say this is an abstract int get age like this, because then it wouldn't be able to increment age, right? So it has to leave it like this. It says it's a property that I can read from and write to. Therefore, cat that conforms to hasAge cannot have a const constructor, simply because one of its functions, which it has brought in using the hasAge mixin, is actually modifying and mutating this instance internally. Therefore, we can't have a const constructor. Okay, so let's see what we did. Abstract int void increment required this age final. Age is final. Okay, we changed this and it should be like this. All right. So after incrementing age, we can have a look at the console and you can see age is now 3. Okay, good. Let's close this and go to example 4 Dart main function, and let's stop this and say fs watch example 4 like this. Good. Now you can also limit mixins to specific data types. All right, so we've had a look at this already. Like when we do mixins like this, mixin can jump on has a speed. What this really did for us is that it limited this can jump mixin to be only available on this mixin. So whoever mixes this mixin in, then they can bring can jump as well. But you can't bring in can jump without bringing in has speed. Okay, and this is the point I want to make in this particular example. So let's have a look at this example. We're going to create a class, and we're saying has 2 feet. Okay, and it just has a constructor. Has 2 feet is a constant constructor. So a class of an object that has 2 feet, just like a person. Okay, so let's then create a mixin, and we say mixin a can run, and we say it is on has 2 feet. So like this. So what happened in here? I mean, this is very similar to example 1, but this mixin is on a class, is not on another mixin. All right, and let's go ahead in here and we say print $runtime type is running. So what we're saying in here is that we have a mixin that is available only on has 2 feet. Okay, so, and this has 2 feet is a class of its own. All right, so if you go ahead in here and say final, you'd be surprised actually at the result. So blah is has 2 feet, and then we say blah, and actually, yeah, and you can see we have no run. But you'd be like, but wait a minute, what happened here? This mixin says that I'm basically implementing on this has 2 feet, but we don't have the run function. Well, what this syntax is actually doing is saying that I'm available on any type that conforms to has 2 feet if that type brings me in, but I'm not available on any other type even if they bring me in. As long as, I mean, I'm only available, basically this is saying I'm only available on any type that conforms to has 2 feet, and that's it. All right. And since has 2 feet is not bringing in this mixing, so it's not saying with this, then you can't actually access it. Then you'd be saying that, but how do I do it? Because with can run, it just doesn't work. Though, I mean, this is how we've learned to like bring in a mixin. And the reason, I mean, the whole syntax, what it's doing, it says, I know that this is a class that this mixin is available on. So then you have to create subclasses of this class in order to be able to use can_run. And I'll show you how to do that. So let's create a class called human, which extends has2feet. All right. And then you can say with can_run. All right. Then we create a constant constructor for human. Okay. And then we go ahead and create another mixin, and we say class has no feet. Okay. And then we say it has a const constructor, has no feet. And then we create a class fish, extends, has no feet. And then we have a fish constructor in here. So then we can go and say human, here human, we create an instance of it. Then we have access to the run function. And then you can see to the printed to the console says human is running. So you see what happened in here. We created a subclass of has2feet. And we said, okay, it extends has2feet. And then we could bring in the can_run mixin simply because can_run is only available on any type that conforms to has2feet. And human does that. And since we have has no feet in here, you can see, okay, and then we say class fish extends has no feet. And if you then in here say with can_run, then you can see that you can't do that because can_run expects your type to conform to we're here. Has 2 feet here, right? And then so you then understand that, okay, I can't conform to can_run because I'm not extending to has 2 feet simply because I'm creating a fish class that has no feet. All right. Sorry, it's a lot of like a biology class or something, but I think you get the point. So here we've created a mixin that's only available on any type that conforms to this particular class. Okay, so the point was in example 1, we saw that a mixin can be on another mixin. This is what we saw in example 1. But here we saw an example of a mixin that is on another class. All right, 2 very different examples. Good, done with example 4. Let's go to example 5. In here, main function, fswatch. All right, here, fswatch, example 5. This is just flying by. We've done it like thousands of times by this point. So in example 5, what we're going to do is to create a mixin that brings hashcode to whoever implements it. So this is actually really, really useful mixin. I've done this a few times before in some projects, and in those specific cases have been very, very useful. Let me show you how to do this. So let's create a pet mixin which has a name and a type, and then using the name, age, and its type, for instance, then so actually it has 3 properties: name, age, and type. And using those 3 properties, it will bring a hashcode property to its implementing type. It's difficult to explain, and just by explaining it with words, we have to actually write the code to see how it works. So let's create an enum called pet type, and we just say cat and dog. All right. And then we say we have a mixin called pet, and it has 3 properties. So let's say it has a type, and we also say that it has a name, so string get name, and also int get age, like this. So 3 properties. And since we have these properties in here, we can then go ahead and implement override, and we say toString. Okay. And then in here, then we say we are a pet of type $type. Our name is equal to $name, and our age is equal to $age. So this is I would say this is the magic of mixins, simply because they create a contract of having a getter of name, age, and type. Then they can actually read those values, even though they're not actually implementing these properties. Okay, they're just saying that whichever type implements me has to have these properties, and therefore I have access to them. All right, then let's go and override hashcode then. So we say override int get hashcode. I think, sorry, is it not hashcode? Oops, hashcode. Let's see. Yeah, there we go. So in here, since we have access to these 3 properties, we can basically calculate the hashcode as well. So let's say object dot hash. All right, and then we say name, age, and type, just like that. All right, so we have access to name, age, and type, and we bring into the hash function and calculate the hashcode. So let's create a very simple equality operator in here as well. And this time we don't want to implement the equality like this, we're going to actually do the equality in a separate example. But for now, let's just say as long as the hash codes are the same, then we're the same object. Okay, so we say other hash code should be equal to our hash code. As long as the hash code is the same, then we kind of consider ourselves to be the same. Okay, and this is not what I'm saying that you should do. It's just because this example is not about equality, so I don't want to implement equality like we should. I just want to focus on hash code. All right, and we'll have another example on doing equality using mixins. So I hope the point is now clear that since we have access to these three properties, we can calculate our object hash using them. All right. So now that we have the hash code and our mixin, we can go and create a class that uses our mixin. So let's say class cat with pet. All right. And we get Visual Studio Code to create these overrides for us. And we're going to create these as final properties. So say final. Final like this, final string name like this as well, and then we will create a final pet type and remove all of these things, the to-dos as well. They making my eyes hurt a little bit. Then we create a constructor, and also we make all of these three required named parameters. Okay, so you can see we have a cat that conforms to the pet mixin, and it has age, name, and type, and therefore we should be able to have hashcode implementation now on this cat. All right, so let's go ahead and create a set of these pets. So we say final cats is a set of cats, and then in here we say we create one cat whose name is kitty1. With the age of 2. All right. The name parameter type is required. Okay, of course. I thought actually we fixed that. Seems like we haven't actually provided the type. So let's go in here and say we don't expect the type because we know cat has the pet type of cat. And instead in the initializer list, we say the type is a pet type cat. Okay. So that issue is gone. Then we go ahead and create another kitty in here. So we say, then we have kitty2. And the age is 3. Then we copy paste the first kitty with the kitty1 and age 2. And since it has the same values and its type is of course cat, something that is done by the initializer, then its hash code should ideally be the same as this one. Therefore, the result of creating this cats set should only include the first kitty and the second kitty and not the third one. Okay, so let's go and say cats for each, and then we print them like this. Okay, let's see what happened print. All right, let's have a look at our example, and then you can see we have kitty1 age 2 and then kitty2 age 3, and that is really just showing that the hash code is working because we take in name, age, and type. All right, and therefore the first and the third kitties have the same hash code. Therefore, they can't both coexist in the same set. Okay, so that was an example of bringing in hash code functionality using a mixin. Let's close that and create example 6. And then we go and create a main function and stop the execution of fswatch. And then we say example 6, as we can see in here. Good. Okay, now in this example, we're going to talk about reflections, and people who are using Flutter are not probably used to this because we don't have reflections in Flutter. But if you're creating a simple Dart application, it doesn't actually have to necessarily be a simple Dart application. It could be a Dart application of any sorts, but you have access to reflections. And in this example, I thought it'd be really fun to basically kind of combine mixins and reflections into the same thing, or into the same entity that we're going to call has description. And what this has description, how do you call it? A mixin is going to do for us is that whichever type that brings in has description mixin into itself is going to have a free description functionality. So if I, for instance, go ahead and say class person, and then I say it has name, age, instead of having to implement toString on this person class and then another class that is called pet and also has these properties, instead of me having to implement toString on both of these, then I can have a mixin that looks at the type which implements that mixin, and then it looks at its properties, and then it will be able to explain what that type actually is. So it will say, here's a type called person, it has a property called name of type string, it has another property called age of type integer, etc., etc. Okay, so that's how we're going to use Dart mirrors or reflections in this example. So let's just go ahead and import Dart mirrors like this. Okay, so then we're going to go ahead and first, I mean, actually, I have to also mention that this particular example is not going to be a full like course on Dart mirrors, because I think that will warrant its own video that is going to perhaps be a few hours long. So I can't go into details about how mirrors and reflection actually works in Dart, but I will do my best to explain as much as possible without doing too much, because otherwise this video is going to be very long. So let's just talk about reflections a little bit and how they work. So reflection works using a mirror system. So the key to reflection in Dart is usually a function called reflect. Okay, so this reflect function will basically give you an object of type instance mirror. I think it's called instance mirror. And this instance, using this instance mirror, then you can get the, for instance, the name of the type which you're reflecting upon. And you can also get that type's declarations. And this declarations will give you, for instance, the variables. It will give you a list of functions that are available on that type. But in this particular example, we're just going to talk about, we're going to look at the variables that a type implements. So we can say here is a person and it has this variable and has that variable, okay? And these variables are described in Dart mirrors using a class called variable mirror. And I think it's a class, I think it's some sort of an abstract class called variable mirror. So in this variable mirror, what we're going to do, we're first going to create an extension on variable mirror, okay? And we're going to say, okay, using a variable mirror, give us the name and the data type of that variable mirror. So let's go ahead and say extension as key on variable mirror. Okay, so imagine a variable mirror is just a variable. It has a name, okay, and it has a data type. So let's say we want to get the field name. So we want to get the name of the variable, and we say mirror system, okay, and then we say get name, and then we say simple name, okay, like this. Okay, what was saying extensions can't declare instance fields. Okay, because we just started writing code directly in the extension, and we instead what we want to do is to have a getter in here. So let's say string get as key. Okay, so here what we did is we extracted this particular variable that we're operating on's simple name. All right, so it's a field name. So if I have a class person, and in here we say final string and name, or final string first name, what we did inside this field name, we literally extracted this first name as a string. So it will literally say first name in here. Okay, then we want to get its data type as well. So let's say final field type is mirror system again dot I think it's called get name, and we say this dot type simple name. Okay, so we have a property called type. I wrote this so you see where type is coming from. It's basically a property implemented on variable mirror. Okay, so we got our name and type. Let's then return. We say field name, and then we will put a parenthesis perhaps, and we say its data type is that. So what this will return in case of person, it will literally say first name string like this. Okay, so we have that getter now on variable mirror. So we can go ahead and use it inside our main mixin. So I'm going to create the mixin in here, and let's just call it mixin has description. Okay, so then we will override to string in here. So now our job is to produce a string for this function. Okay, what I usually like to do is, because I have error lens, which is an extension of Visual Studio Code, which shows me the errors like this in line. They're kind of intrusive, especially if you're working on like a long function implementation, and it will just keep giving you this error until you return a value. So what I usually do is just to say return to do in here. Okay, so then Visual Studio Code is happy. and Dart is happy, then I can focus on my implementation here. Okay, so the first thing we're going to do in here is to get to basically reflect upon this. So we say reflect this, and we say final reflection. And this is a type I was talking about. It is of type instance mirror, if you recall from the beginning of this video, or the beginning of this part of the video, at least for this example 6. So this is how we begin. All right. So then we want to get the data type of whatever type we are implemented on. So remember, has description is a mixin that can be brought on top of any other data type. And this is how we grab the data type, right? So let's just copy that, and then we bring it in here and we say final, final this type, like this. And then we have our reflection.type, simple name, like this. So using this, we got our data type. So if we're implemented on a class called person, then this will literally say person. Okay, just like that. Now let's go grab a list of all the variables that are implemented on the type which implements has description. And we do that by saying final variables in here, and we say get the reflection here and type. It has a property called declarations, okay, and this could be like variables and functions, etc. But we say where, let's see, declarations, values dot where type, and then in here with the where type, say the type should be a variable mirror, like this. So this will then give us a list of all the variables that are available on the type on which we're implemented on. Okay, so let's go ahead and say then, okay, we want to build using this variables. You can see it's of type IEEE variable mirror. So we have a list of variables. We want to construct a list of properties. Okay, so we say final, and it's a map of string and dynamic. We say properties actually a map of, okay, let's not do it like this. Let's just say properties. Properties is a map of string and dynamic, and then we start creating the map. Okay. Then in here we say for final field in variables. We could call it also variable, to be honest with you. And then we say the key of this properties map that we're creating using this this syntax, which is kind of like Python's list comprehensions. The key is the field as key. Remember, we created this string in here as key, and its value is going to go into our reflection get field, and then we say field, that simple name, and then we say reflectee. All right, and let me put a comma in here. Let's see if we can get the code to look a little bit nicer, and then we say toString. Okay, so this is how we're creating the list of properties. You can see it's pretty much just a string. Okay, so what we did is we created a map of strings with the keys of string and the value of dynamic. And this reflectee, you can see it says to have a look at blah 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 if you have access. Okay, it's not really telling us what it is, but this is literally giving us the value of that field basically. Okay, so then we get the toString because we're converting this map to string, and then we could just literally say return this type and then properties like this. All right, I'll explain this reflectee more too soon, don't worry. So let's save that. Now we have that, and it was just a simple example of how to use reflection in Dart. Okay, now that we have that, let's go ahead and create two classes. We say class person, and then let's have name and age, and I'm going to convert this perhaps to a const constructor with two required named parameters, and then we'll have also a house. Okay, so let's say class house, and house is going to have address and rooms. So let's change this to rooms like this, and then this rooms. Okay, so then we are going to go ahead and say, okay, these both have access to our has description mixin. So they're bringing in the has description mixin with has description, and you can see they don't actually have to do anything. They don't have to implement anything special because it has description mixin doesn't have any requirements on its implementing types. It just says that, okay, I'm just a mixin. I'm just sitting here quietly, and I'll bring the toString functionality to you. All right. So now all of a sudden, person and house will get a toString function implemented for them using this mixin. All right. So let's go ahead and create a person. So I'm just going to say final person is this person like this. And then I'm just going to say print the person. And print is going to go and print to string function of this person. Okay, and then let's do something similar for house. So I'm just gonna grab an example in here. I'm just gonna say final house is this. I'm just gonna say print house. So let's have a look at what is printed to the console. So remember this reflectee that we had in here. So let's go here. So this part, you see person name string. This is coming from our as key. So it's literally turning a variable mirror into its name, the name of the variable, and its type, right? That's what this as key is doing. So this is the key to our map. And the value is coming from this reflectee. So this is why I said it's returning the value of the property. Okay, so we're creating these keys and values in the dictionary or in the map, and then we're getting a toString on it. And therefore we're saying this type is equal to property. So it says person is equal to this. This is name is a string, its value is John. Age is an integer, its value is 30. So I think you get the point now. So hopefully you enjoyed this example as well. So it's a way to get a Mixin to do something really useful without its implementing types having to actually do anything. So this is a Mixin that just brings functionality with it. Okay, in all the other examples that we've seen so far, a Mixin kind of created a contract which its implementing types had to actually conform to. So if you have a look at example 1, for instance, here we said here's a Mixin that expects a speed, and therefore we went in here and said person has speed. Okay, so that was an expectation. If you go to example 2, I think also here we created an expectation. We said has first name, expects a first name property. Has last name, expects a last name. Okay, so therefore person had to go and implement a first name and last name. But in example 6, we just created a Mixin that doesn't expect anything. It just says, I will bring functionality to you without you having to do anything. And that's one of the key powers of Mixins in Dart. Let's close example 6 and create example 7 in here. And we say main function and of course fs watch. Okay, example 7. Good, we have that now, and let's just create the last example in this chapter. So in this example, we're going to go ahead and implement equality using Mixins. All right, so for that we need UUID package. So let's go to terminal. I'm going to create a new shell in here, and let's say Dart pop add UUID. Okay, good. So now that we have that, let's close this shell and we get rid of our terminal. Okay, then let's go and create our Mixin. So we say we have a Mixin called hasIdentifier, and this hasIdentifier says, okay, whichever type implements me has to have a string get ID, so a getter for an ID. Okay, using this ID, then we can implement equality. Just like in our previous example, we created toString. I'm not going to go to it again, but you remember that. But in here it says, I'm a Mixin, I expect an ID, and if you give me an ID, I can basically provide you with equality. So let's say override, and I think equality was bool operator equal, and then we have object other, something like this, okay? And equality, the way that we're going to implement it is first we're going to say if these two types are identical this and other, or if they're not identical, they have to have the same type. So other should be hasIdentifier, and other runtime type should be the other runtime type, and the ID of this should be the other's ID. Okay, so this is how we're going to implement equality. What happens in here is that identical will basically say if the current, this data type that is implementing hasIdentifier and the other type that we're being compared with has the same exact memory space, they're residing in the same place in the memory, then they're the same object. Okay, and otherwise we say, or if that's not the case, then the other data type that we're being compared to has to be of the same data type, and the runtime type should be the runtime type of this object, and the IDs have to be the same. Okay, so this is our hasIdentifier Mixin. How do we use it? We go ahead and say class person with hasIdentifier. Okay, then we have to implement, of course, our ID. There we go. Okay, let's say we have a final string, final string ID. All right, and it's a property that we have. Then let's create a final string name as well, and final int age. and then a constructor. Let's make these required named parameters like this. Okay. And what else should we do? So we can now go ahead and actually create some IDs. So let's say final UID1 is a const UID, and then we get a, actually we have to import UID. So let's say import UID like this, and we say UID v4, v4 like that. That's our first UID. Then we create another UID, that's UID2. Then we can create some persons, okay? I'm gonna bring in an example for an instance of person, so we don't have to type that by hand. So this person, and its ID you can see is UID1, all right? Then I'm gonna create another person. I'm gonna say person1 again, like this, and then I'm gonna say it's a person. And for its ID, I'm gonna say UID1. And for its name, I'm actually gonna say John, but with a lowercase j, okay? And I'm gonna explain why we're doing this. So if you look at how we've implemented equality, we don't actually take into account anything else but the identifier. It's just comparing the identifier. If two objects have the same ID, then they're considered to be exactly equal to each other, okay? As long as their data types also match. So two persons with the same ID are considered to be equal. But if you have a person with ID 1 and a dog of the same ID, then they're not considered to be the same object, because in our equality, we're actually checking the runtime type as well. All right, so keep that in mind. Then we will go ahead and create person 2 as well. So let's put person 2. And this person 2 is going to have pretty much the same properties as person 1, but it's going to have a different ID. So you can see person 2 has UID of the second UID. It's the same name as person 1, John, and it's got the same age as person 1. All right. But if you go ahead in here and say if person 1 and person 2 are equal to each other, then we say person 1 is equal to person 2. Otherwise, we say person 1 is not equal to person 2. Okay. Perhaps we could write it a little bit more in an English way. So we could say person 1 and person 2 are equal, like this. And then I can get GitHub Copilot to complete this a little bit better as well. And let's say not. Okay. Then we can compare person 1 with person 1 again. So we say if person 1 is equal to person 1 again. Let's see if GitHub Copilot can clean this up. Yep. This is good. Exactly what I want to write. And then we're going to compare person 1 again with person 2. So we say if person 1 is equal to person 2, person 1 again, sorry, is equal to person 2, then say person 1 again and person 2 are equal, and person 1 again and person 2 are not equal. Okay, so let's just run this example and see what happens in the terminal. So you can see it says person 1 and person 2 are not equal, and this is pretty much what we expected. Right? Person 1 and person 2 are not equal simply because they don't have the same identifier. Then we're comparing person 1 and person 1 again, and they have the same identifier, but their name is different. But that's not what our mixin did. Our mixin doesn't compare the names because it doesn't have access to the name. It has access to the ID and the data type. Since person 1 and person 1 again have the same data type and the same ID, then they're considered to be equal to each other. Okay. And also in the third example, we're saying person 1 again and person 2 are being compared. And if you look at them, person 1 again has the UID 1 and person 2 has the UID of 2. So they're considered to not be equal to each other. Okay. So I hope you also enjoyed this example and this chapter. We talked quite a lot about mixins. They are very useful. They have some shortcomings, but that is something to be expected pretty much from every programming language. It's not just Dart. So really hope you enjoyed this chapter, and I hope to see you in the next one.